Hey everybody, thanks for dropping by. So today we're dealing with something different. What we have here is an older car from 1979, and we're going to be doing a small improvement in the ignition system. See, this car is using the traditional distributor and coil ignition system, and it also has this peculiar problem of too much oil fumes in the engine bay, which along with the road dust form a layer of dirt that sits on top of every component in the engine bay, and of course it sits on top of the connections, the electric connections on the ignition coil, forming an insulating layer that hinders all the electric continuity and causes all kinds of problems in running and idling, and actually too much vibration in idling, leading us to believe that there's some kind of cylinder failure, which is not the case. So what we're going to do is we're going to install this new generation connector right here, which is waterproof and dustproof, and we're going to be soldering the wires on the connectors to make them more reliable, and take it from there and see what happens. So the first thing to do is wet the bolts that hold everything in place, so that we don't break anything, because these bolts haven't been unscrewed for at least 15 years. And the next thing I like to do is tag each wire and number them, so that I'll know where I took out each wire from, and I don't mess things up. I'm just using simple masking tape to tag each wire, and I'm just writing numbers in no particular order, nothing fancy, nothing complicated, simple stuff. And then I'm gonna make a sketch of the cap to where each number corresponds. First, let's see what's going on with the bolts. After a while the bolts are nicely undone. Yep, they can be unscrewed nicely. I can safely remove one of them. Well done. And then I can make a sketch of the cap, drawing all 4 pins, so that I won't have to remember any colors and where I took out each wire from. Simple stuff. The passenger side is this side, the left side. Driver side is the other side. And 1, 2, and 3, and 4. I'm naming each pin in no particular order, but it has to be the same as the number I put in the wires. One final check where each number corresponds, if everything is correct. 4, 3, 2, 1, passenger side, driver side, and everything is correct. And now I can safely disconnect the wires and remove the ignition coil. This ignition coil is metal. The whole housing is a metal with a plastic cap. I believe it's called bakelite, and the holding ring is also metal, of course. And it sits on a metal backplate, on an aluminum actually backplate, where the rest of the ignition system is sitting, which is the electronic PCB, that black thingy on the back over there, that is responsible for cutting the power to the primary coil. First cleaning of the top cap to see what it says. Here's a useful piece of information that the cap can reveal to us. Back in the day, manufacturers used to write numbers and letters on top of the caps. So this cap says BAT and 15 on one side and 1 and RUP on the other side. I'm pretty sure the word BAT refers to battery, and the number 15 is connected to the ignition switch. So I'm guessing the number 15 is the plus battery power through the ignition switch. But the other two, I don't know what they mean. The RUP and number 1, I don't really know what they mean. I'm pretty sure that one of the 4 pins corresponds to the connection for the speedometer to show the RPM. Anyways, we start cleaning everything. WD-40 does a pretty good job of removing all the dirt and grime. An initial cleanup is done here, and in a little while we'll be moving to the workbench to proceed with further cleaning. What I cannot show, here we are in the bench and moving on with further cleanup. And what I don't show on camera, but I did off camera, is use a carburetor cleaner for further cleaning of the metal housing and also this holding ring around the housing and the plastic part. And naturally I can't show everything because this would end up a 3-hour-long video. This carburetor cleaner is also doing a pretty good job. No, correction, not pretty good job. It's doing an excellent job of cleaning all the dirt and oily dust and grime that has formed on the outside. It is a pretty good chance to clean up everything, including the aluminum backplate where everything is sitting, where this ring is sitting. And also the backplate of the PCB. Everything is cleaned off camera, and it's a good chance to clean and sand everything so that everything makes a good electric connection. And next up is the cleaning of the electrical contacts with sanding paper. I'm using 500 grit sanding paper to clean all the electric contacts and reveal the bare metal of the electric contacts. And luckily these contacts are made out of brass instead of just metal. And as you can see here, I'm using pure rubbing alcohol to clean everything up. You can also use carburetor cleaner or straight up gasoline to clean up everything, because I want these contacts to be totally clean of any dust so that the solder will adhere as best as possible. And next up next up is the this part here, the one half of the connector. I am numbering each wire in the connector 2 so that I will know where to connect each wire according to the corresponding number. The numbering on the connector also doesn't have any particular order. I'm just numbering them from left to right, right to left, whichever side I want to put on top, it doesn't matter. So first I'm applying a first layer of solder on the connectors, on these brass connectors. Yep, it sits nicely. And of course a layer of solder on the wires. And then we can only connect the wires on the connectors. Simple stuff, and we check the sketch every now and then to see if we don't mess things up. And after soldering all the wires on their respective positions. It may take a while, but eventually we can solder all the wires on the connectors nicely, and this way everything is totally connected. Okay, first half is done, and next up we can proceed to insulate the connections, the soldering connections with our insulation material. So I'm using this electrical, how do you call it? It is marketed as liquid electrical tape. I'm using the Permatex liquid electrical tape. I'm not paid by Permatex to promote their products. It is the product I found in my local market. There are other companies that make similar products, and this is actually a kind of putty. It resembles honey, which you can apply with a small brush that's included in the bottle, and it forms a layer of insulating material, an insulating layer on top of the connectors that bonds on the connectors, even though this layer is kind of rubbery, has a rubbery substance. It adheres on the surface, but it doesn't stick to it. If you want to remove it, you can easily remove it later after it cures, and it stays elastic, it stays rubbery, and it provides protection and insulation from all environmental elements, and of course waterproofing, dustproofing, and everything. So I decided to test this liquid electrical tape and see how it operates and how it performs, especially in a dusty environment like this particular car, which as it is from 1979, it doesn't have such a good protection against the road dust compared to newer cars. So after applying this, after applying quite a thick layer of insulating material, I let it cure for about half an hour. According to the manufacturer's instructions, after about 4 hours, we can turn on the power, and everything will be nice and tidy. Next up, we need to connect the pins to the other half of the connector. Now, take extra care on this part. First we pass the sealing ring, but we also need to take care when pressing the pins. Now, due to this dirty history of this engine bay, even the inner part of the wires are dirty, so I grind them, I clean them a little bit with the same sandpaper. And right here, this part, I need to point out, you should be very careful with this part when pressing the pins. Of course, the recommended tool is the press tool. If you don't have a press tool, the pointy pliers will do, but you need to be very careful when you're pressing the pins with the cutting portion of the pliers. It is very easy to cut the pins in half if you haven't done this before, so be very careful right here, right at this point, right here. It is very crucial to apply gradual force and not too much, because it is so easy to cut this pin in half. You don't know how easy it is. It needs a little bit of experience, so you can test it in other pins and gain some experience before you press these pins. So be very careful with these pins when pressing them. And after we install all the pins, now we have two halves and two sides where we have the numbers on corresponding wires, so we can easily connect each wire to each pin. an initial setting up before cleaning the backplate. Right here, I haven't cleaned the backplate yet. So number 1 goes to hole number 1. You can hear the distinctive click when it is positioned in place. Right here. And the number 4. And the safety. And of course then we can install the sealing rings slowly and gently. Now be very careful with these sealing rings. They are silicone rubber and they are very soft, and you can really cut them if you use a sharp object, so be very careful with them and move slowly and gently like I do here. And the first connection is quite hard because probably it hasn't been connected before, but every next connection will be easier. Okay, nice and easy. Small management of the cables. Of course, we can remove the tags, and we're good to go. Well, essentially, we can use the car even as we are here without cleaning the backplate, but I decided to clean the backplate and move on from there. I didn't start the car without cleaning the backplate. So right here I did a small cable management, and then right here the backplate is cleaned. You can see the difference in the backplate, and also this black PCB which contains the electronic part of the ignition. This system doesn't use the traditional platinum contact system, but it uses a Hall sensor electronic ignition system. It's a relatively primitive electronic ignition system. This black PCB essentially cuts the power to the primary coil and nothing else, essentially. So after cleaning the backplate and the metal backplate of the PCB with carburetor cleaner, and also the holding ring of the ignition coil housing and the ignition coil housing, everything cleaned with carburetor cleaner, you can see the difference in color. We've connected everything, and I also decided to add a separate wire that is connected directly on the negative wire terminal directly on the battery. Of course, everything has been sanded also with 500 grit sandpaper, so that there will be electric continuity on every part. The metal ring, the coil housing, the backplate, and the electronic module backplate. In a little while we'll see the backplate of the electronic PCB. After tightening everything, everything is nice and tight. And let's check for electric continuity. Let's see what's going on. The housing is okay. The metal ring is okay. Everything makes contact. Okay. Everything seems to be working okay. And let's check with the wire terminal on the battery. Of course, the battery is disconnected. The wire terminal is disconnected from the negative pole of the battery. And right here I'm checking the continuity between the metal parts and the wire terminal. And again. And again. And again. See, there is a little bit of rust on the top cap, but there is still electric continuity in everything. And that's what we need. So before proceeding with anything else, I want to cover and insulate these parts too from the environmental conditions, the dust, the moisture and everything else. So I'm using the same liquid electrical tape on this bolt that connects the wires, that connects everything to the battery terminal. And this way this small part right here will be insulated from the external conditions. Good job overall with that. And let's see again on the battery terminal, everything makes contact. And as a final step, I decided to use some heat conductive paste, the same one that is used on PC processors for cooling. Since this metal backplate on this PCB is probably used for cooling purposes, and touches on this metal backplate, so I decided why not. So let's apply a few grams of heat conductive heat conductive paste on the back of this PCB. And if this PCB is used for electric contact on that backplate, I left the sides empty of paste, and any electric continuity that needs to be done between the backplate and the PCB will be done from that part, from the sides. Nicely done, and we can put it in its position and tighten everything up, and we're good to go basically. Nice and tight. And a final check in the wires and the cables and the cable management. Everything is connected. Let's put the negative terminal on the battery, and we're good to test it. Let's see what we've done. Now, this particular car, before this project, this particular car has been sitting for more than 2 months. Around 2 months. So I'm guessing the fuel in the carburetor has dried up. So I'm not expecting it to start with a first or second attempt. It'll take more than 5 attempts to start. At some point you're gonna hear the here we go. Yep, at some point we're gonna hear the electric pump pumping some fuel on the carburetor. And here it is. Right there, that noise was the electric pump pushing some fuel on the carburetor. Let's see the fourth. Yay, it needs a little bit. Let's give it some time. Yep, well, I think 7th will be the charm. Whoops. Yes, the 7th was the lucky one. And as I said, it's 2 months without running. All the fuel in the carburetor has dried up, and of course it needed a couple more turns to start. But actually this is way better than the previous conditions where we needed at least 15 attempts to start the engine. And before doing all this project and this improvement, the starting was very difficult. The running was quite rough. The idling had too many vibration, and everything was totally different. It wouldn't start in 7 attempts, and it actually flattened out one battery. Some of you may have recognized this distinctive front propeller. For those of you who still haven't, let me enlighten you. This is indeed a 1979 Citroën GS with a 1.1 liter horizontally opposed, aka boxer engine, carbureted of course. And what you are seeing moving is not the camera being lowered, but the car being raised due to the famous hydrodynamic suspension. And you can see the green sphere of the suspension right there. And immediately we can see the better running. We can hear the better running of this car. And right here, here's what I want to show you. This right here is the exhaust manifold, and a little bit of fumes. You may make out a little bit of oil fumes that are present. And this is oil that has dropped before this project, and that's the kind of fumes that was creating all these problems of on the ignition system. And that part, the oil fumes that were leaking from that head cap has also been rectified, so hopefully no more oil fumes in the engine bay. Immediately I can hear the difference in the engine. Before this whole project, okay, now we've lowered the choke. This has a manual choke, and now that we've kind of opened up the choke, the engine idles better. Everything seems to be working way better. I want to test it the next day, how it starts after 24 hours of this initial running, after the whole project was finished. Yep, some vibration is present, but it is totally different than what it was before. And right here, after 24 hours, the engine is cold, and we'll see how it starts right the next day. Whoops. Seems like we also have a starter problem. And right here you can see the gas pedal. I tried to start it without the manual choke right here, but I didn't see any stability. It was about to stall, so eventually I did use the choke to stabilize the first few moments of running, and immediately you can see the car raising. Okay, the hydraulics on this car work great. There has been some work done on the hydraulics on the return lines. These cars were famous for their leaks on the return lines of their hydraulics, but that's an issue for another video. And right here we see how it behaves on the first moments when starting from cold. Good thing on the manual choke is you can regulate it from the engine tube on the carburetor right here. Everything seems to be running normally. After a few moments I'll be opening up the choke throttle and see how it runs. Actually, the picture before the project was very different. After about right here, after about 3 minutes, 3 to 4 minutes of running, I can totally open up the choke throttle, and the engine will have a very different behavior right here. Let's see. Sorry for the angle and the darkness. Sorry for that. And right here. Now I have totally opened up the choke throttle, and the engine has a totally different behavior, totally different sound. There is a little bit of vibration, you can see, but in the previous condition the engine was about to stall. That is around 4 minutes after starting from cold, and in the previous condition the engine wouldn't stay on, it wouldn't run, it was about to stall if we opened up the choke in 4 minutes or even 5 minutes. It had to work for at least 10 minutes to warm up pretty good so that it will not stall. But now with this project and this improvement, we have a better running in idle. We have a better idle even in the first few minutes, in the first 4 or 5 minutes of running. And that's how it is. That's another job well done. Simple project, as I mentioned before, nothing complicated. We just soldered the wires on the ignition coil, and we've insulated them. Just a small improvement. And these new generation connectors seem to be working fine. They seem to be doing a good job. Only time will tell in this case. And in case anyone is wondering, those two white tubes you see here are for the hydraulics and for the vacuum of the distributor. The small tube, the thin tube, is for the distributor vacuum, and the thicker tube is the return line from the accumulator for the hydraulic system. And job well done. Thank you all for watching. You're awesome.